Hi, in this short video we're going to talk about Python lambda functions.
What the what?
A lambda function is basically an anonymous function in Python. It makes a function or allows you to create a function that's polymorphic. So you can sort of use it as a function template or like a function pointer in C++. And you can make that anonymous function into many different functions or do the work of many different functions, but it's just one anonymously defined function. So a little bit of history, where does a lambda function get its name from? In this case, it's from lambda functions that emulate lambda calculus, a language based on pure abstraction formalized by Alonzo Church in the 1930s. This brings up a couple of interesting terms or terminology when going over the history of the name and its source of origin. Whether or not a language is considered Turing complete, all right, and functional versus imperative languages. So what do we mean when we say Turing complete? This is a term used in computability theory that describes abstract machines called automata. An automaton is considered to be Turing complete if it can be used to emulate a Turing machine. That's also called computationally universal. Most modern programming languages are Turing complete. An example of one that is not is HTML. All right, hypertext markup language is not Turing complete because it cannot actively modify or change the state of the system. Only when you combine HTML with another language like JavaScript could it then be considered Turing complete, because then it could do things that modify or change the state of the system. Another example of something that would not be Turing complete would be regex. Regex expressions are not considered Turing complete because they include back references, and a finite automaton cannot handle back references. What's regex, you ask? We'll cover that in a future video. But you can do a lot of wonderful things with it. Regular expressions, sets of characters that you can use and apply syntactic rules to and use for manipulating data and matching different patterns. Okay? A Turing machine, what's that? Mathematical model of computation describing an abstract machine that manipulates symbols on an imaginary strip of tape according to a table of rules. This model is capable of implementing any computer algorithm despite its simplicity. And you've probably heard of the Turing test, whether or not a computer could fool a human into thinking that it was a human, another human, and not a computer bit. All right, so functional languages like Haskell, Lisp, Erlang, the programming with these languages emphasizes abstraction, transformation, composition, and purity. And by purity, we mean no state or side effects. In contrast, typically the languages that we program with are imperative languages. So Fortran, C, C++, Python, program with statements that manipulate flow step by step with detailed instructions. This promotes mutation and requires managing system state. Okay? When were lambda functions added? As far as I can tell historically, 1994, when map, filter, reduce, and the lambda operator were added to Python. So even though Python is an imperative type language, like C, it's not a functional programming language. Python can emulate functional abstractions with things like a lambda function. Okay? So the syntax is just, you're going to say lambda and then your arguments for your anonymous function. And let's look at the first example. We have a very simple example here. Z equals lambda, the keyword lambda, and then x. And then whatever we pass in as that parameter, we're just going to add 777 to it. So if I have z and it points to an anonymous function that takes a parameter x and just adds the value 777 to it, what will happen here? If I pass in 3, it'll just add that 3, right? It goes in as the parameter as the argument x, and adds it to 777. So I should get 780 as the result, right? So let's run this, and I'll hit F5. And see, here's our 780 as expected. Let's take a look at another lambda. Here in our second example. So now I have a lambda, an anonymous function that takes two arguments, right? Two parameters. So again, the keyword lambda, defunct will point to our anonymous function, our lambda, and then we're just going to multiply those parameters together. So if I were to then take defunct, which points to my anonymous lambda function now, and I pass in 7 and 444, it's just going to multiply those values. If I hit F5 to run it, 3,108 would be the result, right? So, that illustrates the syntax, how you would create a lambda function, but you're probably wondering, what's the usefulness of that? Well, let's say, here's a hypothetical. Let's say that you wanted to create a sort of a function template, not an actual function, but a function template. And it could be used for a series of things. So let's say you want to be able to square a number, and then you want to be able to cube a number, right? So, you could exponentially multiply it by itself, or multiply it by itself and cube it, you know what I'm saying? Or let's say, in this example here, let's say that we just want to create functions that multiply something by 10, okay? Or by whatever value we pass in. So we'll double or we'll triple it. Well, I can make one function here, all right, called lambda math, and it returns lambda. It's just an anonymous function, all right, y, and then the result of multiplying y times x, and then it just returns y, and it basically assigns it to itself, okay? If I did that, look, this is basically a function template. The way I define this lambda, it's nested, the definition's nested inside of my outer function, lambda 03. So that's my anonymous function. That's my function template, right? Lambda math. Now I'm just going to take a variable, basically kind of like a C++ pointer, an instance, and I'm going to point to and create a variation of that, from that anonymous function template, that lambda. I'm going to create one that will double whatever I pass in. And then I want to create another function called tripled from that template, that anonymous lambda function, that would triple, multiply by 3 what I pass in. So doubled multiplies by 2, tripled multiplies by 3. It's a very simplistic example, but using this technique, I can take that one anonymous function, and let's say that I had dozens of related functions. And if I didn't want to create or write a separate, code out a separate individual function for each process, then I could use a lambda. I could use an anonymous function, and then I could code the relationship, and then I could just create variations on the theme using that lambda like a template, and just using a variable to build sort of an instance of that function, and use that to then call the function built from that anonymous lambda function that I previously defined. So that's what I'm doing here, right? Doubled. We'll create a lambda math anonymous function that multiplies whatever I pass into it by 2. Tripled, we'll take whatever I pass into it and multiply it by 3. If I do that, look, here's how I call the function. And to the print method, I just say doubled, and I pass in 10. Well, it's going to take that 10 and this 2, y times x, in my anonymous lambda function and multiply it. And so, in this case, 20. And then in this case, here 10 tripled, well, it's just going to take that 10 and that 3, and in my anonymous lambda function, multiply it y times x and return the value. So, and as expected, here's our result, 20 and 30. So, you will see lambda functions used in code, and there's a lot more to this topic. But we'll keep this video short for now. This is just an introduction. So if you see that lambda keyword, just understand that in Python, that's an anonymous function, sort of like a function template, or could be used like a function template, or maybe a function pointer.